Okay, this question, I received this question about how to use the comparison test, so I thought I'd record this and put it up so that anybody can look at it. So just to quick review, comparison test, either the direct comparison or the limit comparison test, they're both used the same way. And it has to do with the what's happening when n is when it goes to infinity. So basically the n behavior of the series. So basically, let's say we start with the series called an, and we're trying to compare it to some other known series that we already know converges or diverges. So and the two situation is this. If we have another series that converges, like Bn, like say a P series with P greater than 1, and we can show that An is less than Bn at some point, when n gets very, very large, then what we're saying is that this is the visual representation that really helps me, that if we have a known series that converges, that means, and we're talking about a non-negative series, so it squeezes and it goes towards 0 or some limit, then an is less than bn at some point, or the series, that means it gets squeezed because it's positive. It can't go below 0. So it gets squeezed between Bn and 0. That means An has to converge. Okay, so that's the comparison test here. So that's the comparison test to show that An converges. If you can compare it to a known converging series and that it's being squeezed between that converging series and 0, basically. Okay. The other thing is that you can show that it diverges, and the picture is the other way around. So if, say, a known series Bn diverges, let's say harmonic series 1 over n, or any other series that you can think of, and you want to show that An diverges or do a comparison, and it turns out that An is greater than Bn, that means it's being lifted up, and since it's positive, it's going away from 0, and it has to also diverge. If Bn diverges and An is higher than that, it has to diverge as well. It's going away from 0. So that's the two different ways that you can show either convergence or divergence by using a comparison test. So this is about using, you want to compare it to something simple that you know are converging or diverging, like the P series or harmonic series, or some geometric series if you can go that far. But it's usually these problems I've seen are either against a harmonic series or a P series. Okay, I hope this is helpful.